In this lesson, we're going to talk about solving trig equations. Now, suppose we're asked to solve for theta, where sine theta equals 0.5. We know that sine theta represents the y-coordinate on the outside of the unit circle, so we can draw a unit circle. That's a poorly drawn circle, but you get the idea. And then we can identify the points on the outside of the circle that have a y-coordinate of 5. If that's a little unclear to you, here's what we're saying. Because it's a unit circle, we know that the origin is right there. Unit means the radius is 1. So we know that up top we've got that point right there has a coordinate of 0, 1 because the radius is 1. Well, that means halfway up, we're going to have a y-coordinate of 0.5. Well, what we do is we identify any points on the outside of the circle that have a y-coordinate of 0.5, and they would be this one right there and this one right there. So that's all we're doing. And then what we do is to each of those points, we draw a terminal arm. Now, our goal is going to be to figure out what is that angle right there and what is that angle right there. Okay? Well, as you can see, I called the first one theta 1 and the second one theta 2. And we see that theta 1 has to equal 30 degrees and theta 2 has to equal 150 degrees. The reason for that is because on a previous video, we talked about the unit circle. And we talked about how there are certain points on the outside of the unit circle that it's good to have memorized. Well, one of those points is 30 degrees. And at 30 degrees, if you'll recall, we said that the x-coordinate is √3/2 and the y-coordinate is 1/2. And then similarly, at a point of 150 degrees, at an angle of 150 degrees, we said the x-coordinate is -√3/2 and the y-coordinate is 1/2. Well, we're talking about sine theta, so we're interested in the y-coordinate. We're interested where the y-coordinate is 1/2. And so in this example, we actually know this already from our memorized winding function or unit circle values, and we can, spare ourselves the need to use a calculator, and we can just give the answers. But suppose we had a situation where we didn't already know those values. So suppose we hadn't memorized those values on the unit circle, and we didn't know that sine 30 degrees is 0.5 and sine 150 degrees is 0.5. Then what would we do? Well, in that case, we'd use our calculators. And here's what we would do. We would enter sine inverse of 0.5, and the calculator would tell us, if we're in degree mode, that the answer is 30 degrees. Now that answer will refer to one of the angles on the outside of the unit circle. So just by looking at this, again, remember this is always 0 degrees. 0 degrees is always located there. We can say, okay, rotating in a positive direction, I see that this initial angle here, that's my 30 degrees. All right, so I'm happy with that. But how are we going to determine theta 2? Well, here's our strategy. What we're going to do, we're going to color in a blue wedge that we know has a magnitude of 30 degrees. So right there, I know that has a magnitude of 30 degrees based on the thinking that just went earlier. Now, what I want you to do is realize that this circle is symmetrical, so that y-axis right there is acting as a mirror. Similarly, the x-axis is acting as a mirror as well. Well, since that y-axis is acting as a mirror, that means this reflection right there, that's the same size. That's also 30 degrees. Okay? And so I see that that second blue wedge is also 30 degrees. Now what I do is I go to 0, which is right here, as we said earlier. I go to 0 and I draw around to here, and I ask myself, how far have I gone? Well, if I had to guess, I would say going all the way to here would be 180 degrees, but that's not what we just did. We stopped short. How far short of 180 degrees did we stop? Well, exactly 30 degrees. In other words, we just traveled 180 degrees, but stopped short 30 degrees. so we traveled 150 degrees. And so we can see that our angle is 150, our second angle. Okay? And there we go. We've got ourselves a couple of answers. One answer is 30 degrees, and one answer is 150 degrees. All right, now we're feeling happy about that, but what if we change the domain? See, what was unspoken in that question right there is we were kind of assuming that we were talking about the first positive rotation around that unit circle. But what if we're not talking about that? We can, have any domain we want. We can, so instead of thinking of theta as an angle between 0 degrees and 360 degrees, let's think of theta as an angle between negative 360 degrees and positive 720 degrees. Now, this might sound more difficult, but it's not. The hard work was already done. Once you find an answer at each terminal arm, now all you have to do is add 360 degrees or subtract 360 degrees at each terminal arm until we're out of the domain. So if you go back to what we had earlier, this is what we had. Now, we said earlier that this is 30 degrees. Well, if I do this, I go around a full 360 and then another 30, I'll end up in the same terminal arm. So in other words, 390 degrees will get me to the same place. Similarly, look at this other one. If I go a full 360 and then add that second angle's worth, what I've done is I've gone 360 plus the 150, I've gone to 510 degrees, and I end up back on the same terminal arm. So what we can do is we can add 360 degrees or subtract 360 degrees from the value that we get at each of those terminal arms until we're outside the domain. In other words, I started at 30 degrees. I added 360 degrees as shown, I got here. I added another 360 degrees. 750 degrees is an angle on that terminal arm as well. You'll recall we call those coterminal angles. So 750 degrees is an angle there, but why is it wrong? Well, it's wrong because at the start of the question, we said we're going to let our domain be from negative 360 degrees to 720. 750 is outside of that domain, so it doesn't count. Now, similarly, we can actually subtract as well. We can go in the reverse order, and that would be, so if we did that angle I just drew, that would be like going negative 360 degrees, but actually kind of reversing course and going another positive 30 degrees. So it would be like going negative 360 degrees plus 30, which would be negative 330. So you can see that we can get that value of negative 330 by simply subtracting 360 from 30. Okay, well, let's do it again. If we do it again, we get negative 690. Now, negative 690 degrees is on that terminal arm that we're looking at right now, but it's not in this domain, so we don't count it. And we do the same series of steps with the angle, with the angles at the other terminal arm. These angles are all coterminal with each other. These angles are all coterminal with each other, and we've got ourselves a full set of answers that satisfy the equation and are in the domain given. Awesome. Now, what if we don't have an angle on the unit circle, a known angle? What if we have something like this? Sine theta equals 0.8423. Oh, good golly. Well, we know that the first thing we want to do is we want to draw a unit circle. Please get used to that idea. And then we know that sine refers to the y-coordinate on the outside of the circle. So we're saying this y-coordinate's 0.8423. Well, remember, the top of this circle right here, up at the top of that circle, that's equal to 1. So 0.8423 is right about here and right about here. I know it's not well drawn, but since 0.8423 is slightly below that 1, we can draw a couple of terminal arms out to those sides, and that's what we've shown in our diagram down here. Okay, we've drawn a couple of terminal arms out there. Now, hopefully, you can see that the y-axis is going to act as a mirror, and whatever the size of this angle is going to be the same as the size of that angle. Well, we do our sine inverse. We use our calculator. Sine inverse of 0.8423 is 57.4. This answer will be somewhere on our diagram. And we see, yeah, that looks like right about here. Remember, this is 0, and the positive x-axis is 0. Counterclockwise is positive. So that's about 57.4 degrees. I can believe that. I'm happy with that. And so we can say that in blue there, we've just drawn an angle that's roughly 57.4 degrees. Well, since that's 57.4, another blue wedge on the other side will also have a magnitude of 57.4. And then we go back to 0 and we say to ourselves, how big is this angle? Well, what we do when we draw that angle is we actually, you can think of it this way if you want. You can say, well, we go a full 180, that's positive because it's counterclockwise, but then we go a negative 57.4 because that's counterclockwise. So that's like saying we went a positive 180 and then a negative 57.4 to get us to 122.6, I believe. And that's what happens. Okay? And so we've got an answer at the second terminal arm as well. Now, once you have answers at each of the two terminal arms, life is good, because all you do is you add 360 and subtract 360 multiple times if necessary from the 57.4 and then also from the 122.6, and you just pick off all the values that are in the domain given. Okay, there we go. And now you can state your final answer. All of these theta values lie in this domain, and they all satisfy this equation. All right. Well, what if we have a negative sign value? Well, that would just mean that the y-coordinate is underneath the x-axis. So we just draw a couple going down. No biggie. Then what we do is we use our, because what I'm saying here, just in case you're not sure, I'm saying that since this is a radius of 1, my y-coordinate down here will be negative 1. So a y-coordinate of negative 0.4153 is probably right about there. And so I pick off the two values on the outside of the circle that have that y-coordinate, and then I draw my terminal arms out to them. Okay? Now, we use our calculator to sine inverse negative 0.4153. It tells us negative 24.5. Remember, negative means that we're moving in a clockwise direction. So that actually looks like negative 24.5. There it is. All right, we got the answer for one of our terminal arms. But what's the value of the other terminal arm? I would like to know what this angle equals. Or, for all I care, let's find out what this angle equals. It doesn't matter which value we get first. The first one would be positive. The second one would be negative. Well, what we're going to do in this case, let's find the positive version. But if you found the negative one, that would be fine too. What we're going to do is we're going to say, okay, what we have here is a situation where each of those wedges has a magnitude of 24.5 degrees. To get to the first one, we went clockwise, which is negative. To get to the second one, we're going to go a full 180 and then continue going counterclockwise, which is positive, another 24.5. So that would be 180 plus 24.5, which is 204.5 degrees. We've now got an answer at each of those terminal arms. Now what we do is add and subtract 360 at each terminal arm as necessary until we get all the values required from that domain. When we do that, we have the values shown, and we can make a great therefore statement. Okay? Now, what if we have cos? Okay, well, what you might want to remember here is that cos theta on the unit circle references the x-coordinate. So basically, I'm saying to you, when I say cos theta is 0.3455, that the x-coordinate on the unit circle is 0.3455. Awesome. So what I do is I draw a unit circle. I know that this value way out here, that has an x-coordinate of 1. So an x-coordinate of 0.3455 would be right about there. Well, that means that this point on the outside of the unit circle and this point on the outside of the unit circle have x-coordinates of 0.3455. I go to the origin, always go to the origin, and draw out a couple of terminal arms. Those are the two angles that I want to find, which are, that's what this diagram shows right here. So once we do that, we use our calculator. The cos inverse of 0.3455 is roughly 69.8. So I can believe that this is 69.8 degrees. I'm happy with that. And I put that answer there. Now, if you look at it, that x-coordinate that you see there, that's a mirror. And that means that the if that blue wedge there is a magnitude of 69.8 degrees, this wedge that I just shaded in, that'll also be a magnitude of 69.8 degrees. We shaded it in green there. Now, if I go all the way around the circle, what I've just done is I've gone a full 360 counterclockwise, but then backed it up and went clockwise 69.8. So that would be like doing a full 360 counterclockwise and then going backwards 69.8 degrees, which would get me to 290.2. Okay. Now, to be honest with you, what some people do is they say, oh, sir, if this is 69.8 degrees, then I know that's the same size. It's in the negative direction. I'll just call it negative 69.8 degrees. That's fine as well. Okay. But all we're really interested in is that you get a valid answer at each of those terminal arms. Now, just add and subtract 360 as required to get all at each of those terminal arms to get all of the values inside the given domain. Aren't we happy? There's the great therefore statement at the bottom. And this question here, cos theta is negative 0.8256. What we're doing here is looking at a situation with a negative x coordinate. Okay, well, we say to ourselves, okay, I know that that point way out there has an x-coordinate of negative 1. So I know an x-coordinate of negative 0.8256 is right about there. We go at those points on the outside of the unit circle, draw our terminal arms. Okay, sweet. Now we use our cos inverse button, and it tells us that one of the answers will be 145.6. And we can actually see that. Okay, yeah, that's 145.6. Well, the x-axis is acting as a mirror, so is the y-axis. But in this case, we're thinking of the x-axis acting as a mirror. And so that means underneath we have another region with a magnitude of 145.6. So right away we can say to ourselves, okay, if I go in the negative direction, the same amount, I'll get an answer of negative 145.6. That's one way of looking at this. Or another way of looking at this is to say, okay, I'll go a full 180, and then I'll go a full 360, all in the positive direction, but then I'll back it up 145.6 degrees. That takes a little longer to think of it that way, but it's also valid. So 360 minus 145.6 equals 214.4. Neither answer is better than the other one at this stage. We just are happy to have a couple of answers, one at each terminal arm. Now we add and subtract 360 as necessary at each terminal arm, and we get all the values inside that lovely domain, and we give a great therefore statement. Okay. So hopefully that was meaningful.